Welcome back. In the previous session, we trained a model from scratch to recognize cats and dogs. In this video, we'll see how can we train a model much faster via transfer learning. This time, we won't train our model from scratch. We will transfer the weights from a model that was trained on ImageNet and continue from there to fine-tune it to classify cats and dogs. Let's first create a Boolean variable that'll tell our model whether we train the entire model or to train the last layer only. If we are fine-tuning only the last layer, then we should optimize the variables only in the last layer and keep the rest as is. Now let's scroll down to our optimizer and modify it to do so. If we are training only the last layer, we should get a list of trainable variables in that layer. In the MobileNet model that we use, the variable scope for the last layer is named MobileNet v1 logits. Now we'll tell the optimizer only to optimize these variables and leave the rest as is. Otherwise, we're going to call this optimizer function without feeding the variable lists like we did earlier. I added this function while I was not recording. What it does is that it finds the variables that our model and the model that we want to transfer the weights from have in common. This allows for transferring the weights even if the model that we transfer the weights between are not identical. I'll add one more thing here, which is not relevant to transfer learning but might be useful. TensorFlow allocates the entire GPU memory available by default. We can easily change this behavior by creating a config function and enabling GPU memory growth. Now we can put this here and can run more than one process on a single GPU if needed. We'll also need to change how we restore the variables from a checkpoint. We'll use our new variables to restore function to find what parameters to restore from this checkpoint. Then we'll pass this list of variables to the saver . So where do we get this checkpoint from? In this example, we'll download it from this page under TensorFlow's GitHub repository. I'll post the link below. Here's the checkpoint for MobileNet, for example. All of these models were trained on the ImageNet challenge dataset. I have already downloaded this dataset and extracted under the checkpoints folder. Now we need to create a file here named checkpoint and point it to the checkpoint file where we'll load the weights from. Now we're ready to run this code. Let's go one level up and let the fine-tuning begin. Here we successfully loaded the parameters from this checkpoint that we're transferring the parameters from. This will run much faster than training from scratch since we have much fewer parameters to optimize. It'll also converge faster, but I'll fast forward it anyway. After only minutes of training, we got a validation accuracy of 87%. Clearly, this is not the state-of-the-art performance. We'll need to train it for longer and fine-tune the rest of the parameters as well to further improve the performance. Alright, that's all for today. I'll cancel this here, but you can continue it further. I hope you found this tutorial useful. Subscribe for more videos, and as always, thanks for watching, stay tuned, and see you next time.